Okay, okay, my dear students. Today I am going to take one session on optics. Now, this is a topic from second year from light. It has got two chapters actually: ray optics, which is also called geometric optics, and wave optics. So we are going to discuss about actually the ray optics part. Okay. Okay. Primarily in this topic, actually, what we study is we study light as rays. If the light rays are parallel, it is called paraaxial beam. The speed of light is 3 into 10 to the power of 8 meter per second. Actually, light is an electromagnetic wave, but we study it as wave in another chapter called wave optics. Now, the light is associated with some phenomena, such as the first phenomena is reflection, second is refraction. We are going to study about these two subtopics, reflection and refraction, across different type of surfaces. It can be a plane surface or it can be a curved surface. That we will see topic by topic. So basically, what happens is, suppose a light falls on a surface. Okay, if some light rays fall on a surface, actually here billions of light rays fall. Actually, we are not going to study all the light rays. We are going to study only one or two light rays. Okay, so the same pattern is repeated for the other light rays. Okay, so here what happens is, some of the light rays may be reflected, which in other words like bouncing back. Some may be transmitted through the medium or the surface. So this we are calling bending of light, which comes under the refraction category. And some part of it may be little bit absorbed also. Some part of it may be little bit absorbed. But we are not going to study about this. We are going to study only about the reflected light rays and the what happens if it is refracting. Okay, just a minute. Okay, now when we start with reflection, suppose if I start with reflection, first we need to understand the law of reflection. Okay? So if there is a reflecting surface, so when we are talking about reflection, we are actually ignoring the refraction part. Say students, it is like this: billions of light rays are coming actually. Not all are reflected, not all are refracted. Some may be reflected, some may be refracted. Okay. So while we are studying about reflection phenomena, we bother about only the reflection part. We will not be discussing about the refraction part. That will be discussed separately. So if a light ray comes like this, we have to draw a normal to the surface. It reflects like this. Okay. So this light ray is called incident light ray, and this is reflected light ray. The angle must be considered from the normal to the surface. So this is your angle of inclination, sorry, angle of incidence, and this is your angle of reflection. Remember it, that whenever you take a surface, you must draw the normal line to it, and then the angle must be measured from the normal side only. Okay. So according to law of reflection, angle I is equal to angle R. Now here there is a condition actually. This incident light ray, reflected light ray, and this normal line, they all should be in a same plane. They must be in the same plane. Okay. This is one important condition you should never forget. They must be in the same plane. So what is the same plane? We call it a paper test. You should be able to do a paper test. I should be able to stick a paper on all the three light rays, on all the three lines. Okay, it may be in XY plane, it may be in YZ plane. So if I put a paper there, the paper should touch all these three lines. That is the meaning of being in the same plane. Okay. So regarding this, we can see a small numerical. So actually, how do we make the calculations? If you just select one question, I'm looking for a question which will explain this concept, actually how to apply this law of reflection. Mm, First, we look into this question. Let us have a look on this question and try to apply our concept that we have learned right now. So here, actually, two plane mirrors A and B are aligned parallel to each other as shown in the figure. So a light ray is incident at 30 degrees, which is mentioned in the problem as 30 degrees, just inside one end of A. The plane of incidence coincides with the plane of the figure. The maximum number of times the ray undergoes reflection. So if I draw a slightly bigger picture, like there are two plane mirrors like this, and one light ray is entering here at 30 degrees, and this length has been given as 2 root 3 meters, let us say, and this width is mentioned as 0.2. Is asking you how many times reflection is possible. So it is a case of multiple reflections. We will see why it is multiple reflections. Just a minute. Okay, let me have a look on any comments have come. Minutes like this, and one light ray is entering here. Okay. At 30 degrees, and this length. Yeah. So as I told you that you have to apply this concept of law of reflection. So we have to draw the reflected light ray. Okay. So the reflected light ray, if this is the normal line now. So it will make 30-degree with this vertical line because angle of incidence is equal to angle of reflection. Then again you need to drop a vertical line, a normal line here. So because this is 30, this angle will be 30 as these two are parallel lines, and again draw the reflected light ray. Again there is a possibility of reflection, and so on and so forth. All right, this will go in this pattern. So it's asking you what is the maximum number of times the ray undergoes reflection. So we need to see how many reflections are possible actually mathematically. How many reflections are mathematically possible? If you see in this triangle, this side is given as 0.2, so I can work out x. If I call this distance as x, I can work out that. So I can use trigonometry and I can find that. So I can say x divided by zero point 0.2, that is opposite side by adjacent side, is equal to tan 30. Opposite side by adjacent side is equal to tan 30. That means x divided by zero point 0.2 is equal to tan 30 is the value of tan 30 is 1 by root 3. It is 1 by root 3. Sin 30 by cos 30. So x would be equal to zero point 0.2 divided by root 3. So 0.2 can be written as 2 by 10, which is 1 by 5. So basically it is 1 by 5 root 3. So the value of x is 1 by 5 root 3. So here it is only half triangle. So the value of this one would be 2x, arguing in the same fashion. So this value will be equal to, so that value, see, you can say here that this is the first reflection. This is the first reflection. This is the second reflection. This is the third reflection. This is the fourth reflection. We have to find out how many reflections actually it is possible. Okay. So how do I do that? So it would be like this. I should find out the value of n in such a way that I consume this 2 root 3 value, because if the ray goes beyond that length, no further reflections are possible. So it is like this. I can say x plus 2x plus 2x etc. should be equal to 2 root 3. If this becomes greater than 2 root 3, this we have to see how many times it is happening actually. Okay, let us say it is happening n times. So if it is exceeding that 2 root 3, that means the ray has gone outside the plane mirror's point of view. Okay, field of view, sorry. So it is like this. So if I take x common, it is like 1 plus n into, okay, I'll do one thing. We will put the value of x here. X value we have got it as 1 by 5 root 3. The value of X is 1 by 5 root 3 actually, plus 2 by 5 root 3 plus 2 by 5 root 3 and so on is equal to 2 root 3. Okay, this we are calling it as n times. Okay, so if you take 5 root 3 common, it becomes 1 plus 2n by 5 root 3 is equal to 2 root 3. Okay, so if you cross multiply, it becomes 1 plus 2n is equal to 5 2s are 10, 10 into 3 30 it is. So 2n is equal to 29, n is equal to 14.5 it is coming. But 14.5 is not possible, right? So we'll take the next count. So 14.5 into 29. 29 plus 1. Total 30 reflections are possible. In this case, total 30 reflections are possible according to the given dimensions. So option 2 would be a more nearby answer to this problem. Okay. If anybody has any doubt in this, you can just comment there. I will reply. Okay. So this is about uh, how to apply the law of reflection in a problem actually. Okay. Now we will proceed to the next concept. So let me share a figure with you. So here there is one concept actually, uh, which is like this. Okay, suppose there is a mirror is there, a plane mirror is there. This is your incident ray, right? And let us say this is the normal line, and this is your reflected ray. Okay. Now, if I keep the incident ray constant and I rotate the mirror by let us say theta, the reflected ray will rotate by 2 theta. This is a very important concept you can understand. So if I take a plane mirror and if I keep the incident ray constant and I rotate the mirror by 2 theta, by theta, the reflected ray will rotate by 2 theta. This can be proved also. I'm not going into the proof part. If you want, sometime I will prove it also. But this result is very useful and it is asked in exams. So it's a direct answer. Okay. Now why this happens means when you're rotating the mirror, basically even though you're not changing the incident ray, you're changing the normal line, right? So the angles involved are getting changed. So this I'm giving the hint. You try to derive yourself and comment there. All right. If you want, I'll prove it and I'll show you why it is 2 theta. Okay. Just take this very useful result which is required in the law of reflection. Okay. Next, I will go to vector formula. I'll share the vector formula and we'll try to solve one problem if the question is asked in vectors. Okay. Just give me a sec. I'm trying to locate a problem. If the problem is not there, no, we'll create a problem and we'll try to solve that. So these type of questions they ask in JEE, they will not ask you direct straight questions, but questions that involve some concepts, some tricky concepts. So question related to vector I'm not finding, but I'll try to create one and I'll explain you. All right, you can take the formula and we will see how to apply this formula. Yeah. So this is that formula you can note down. And suppose the question is asked in vectors. So here E1 cap, E2 cap, E1 cap is the incident ray. It is a unit vector. E2 cap is the reflected ray and it is the unit vector. Unit vector means the mod value is equal to 1. The mod value is equal to 1. That is called unit vector. What is this n cap? N cap is a normal vector. Okay. So if I know the incident ray vector, I can find the reflected ray vector using this formula directly. You can take the result. E2 vector is equal to E1 vector minus 2 E1 dot n cap into n vector. This is a normal multiplication. This is a dot product. So we'll try to analyze the situation using a problem. Suppose in a problem he gives that, I'll draw the figure. Okay, he will give that incident ray, let us say this is O, this is A, and this is B, and let us say this is C. He has given the OA vector, let us say OA vector is I plus J minus K, and he has mentioned that the normal vector is I plus K. That is my normal vector. Okay, so he has given the vectors. Now he is asking you what is the reflected ray in terms of vectors. So we will directly apply this formula, but because the formula is given in terms of unit vectors, we have to convert this into unit vectors. So the direct answer would be E2 cap is equal to E1 vector. E1 vector will be this one, I plus J minus K, okay, minus 2 into E1. E1 is incident ray, I plus J minus K dot. What is the normal vector given? I plus K. Okay, multiplied by a simple multiplication with I plus K. So we need to simplify this. Okay, now because it is a unit vector, we have to divide by the mod values. So the mod value here would be what? Root over 1 plus 1 plus 1. It will be root 3, and this will be root 3 actually, and this will be root 2 and root 2. Why I divided by mod value? Because of the formula, we are talking about the unit vectors. We are not talking about the overall vector. Okay, so my E2 cap would be equal to I plus J minus K divided by root 3 minus, first we will perform the dot product. How do we perform dot product? We have to multiply I with I, J with J, and K with K. So I dot I is 1, so I will write here minus 2 into, it is plus 1, J dot, this side J is not there, so that will become 0, and minus 1 minus K cap into plus K cap, it is again minus 1 divided by, here root 2 should be there, root 3 into root 2, it is root 6. But you can see that this term is becoming 0. So my reflected ray vector would be equal to I plus J minus K divided by root 3 only. This is my unit reflected ray. If I want the actual vector, I need to multiply with the mod value, then I'll get the actual full vector. Okay, you can just go through this problem and tell me, do you have any doubt? Actually, I was unable to locate any particular problem from the textbook or any standard material, so I just created to explain you a point. Okay, okay then. Okay, so next concept would be, yeah, let's will talk about reflection from a plane surface. Okay, we'll talk reflection from a plane surface. So the topic is reflection from plane surface. So what are the rules? I'll draw a plane mirror here. Now this part is called silvering. The other side only will reflect. Okay. So if I place an object here, we have to understand where it will form the image. That is what we are trying to explore here. So we have two types of object actually. One is called point object. The point object looks like this. It's called point object. And one is called extended object. It is drawn like this. Okay. So remember one thing. If I want to form the image of any object, whether it is a point object or a extended object, I must be having minimum two rays. Three is preferable for cross-checking, but the concurrence of the convergence actually, the convergence of minimum two rays is required to decide the nature of the image and where exactly the image is formed. So here I have taken a point, I have taken a point object. So from this point object, actually billions of light rays are going towards the mirror, but we are interested only maximum two or three rays, which will help me identify where exactly the image is formed. So I will take one light ray like this, which is going and falling on the mirror. So you know that after reflection, it will go like this. The ray came like this, the ray went like this. I have to draw a normal line here. So you know that angle of incidence is equal to angle of reflection here. And I will take another ray. Maybe the ray is coming like this and it is going like this. So I have to draw a normal here. So angle of incidence is equal to angle of reflection. Now I want to know where is the image formed. So what I need to do here is I need to back extend it. I need to back extend it. Okay, na? I have to draw it more carefully like this. So this is the point where if you back extend the this rays, they are going to converge. Okay, so the image of this point object is formed the other side of the plane mirror, plane surface. Now this type of image is called virtual image. Always remember the image which is caused by dotted lines, we call it as virtual image. Okay, and because we are now dealing with the point object, if you solve the geometry, I'm not going into the solving of the geometry, but if this distance is x, this distance also will come down to be x. You have to just take the congruency of the ticked triangles, and using the congruency rule, we can very easily prove that the image distance is equal to the object distance. However, the object is on the, this object, which is a virtual object. I mean, the image is a virtual image. It is formed on the other side of the plane surface. Okay. So similarly, if I take a extended object, if I take an extended object, we can repeat the same thing. If I take an extended object, okay, Always remember, just now we have proved this point will have an image here, right? And if you take, if you argue in a similar way, if you take the rays like this, and if you take the rays like this, after falling on the plane surface, you will find the rays will make an image at exactly this point. So here we have understood that it forms a virtual image because it is on the other side of the plane mirror, and you see it is in the upright position. We can call this image as virtual. We can call this image as virtual. We can call this image as erect. Erect means in the same fashion. Suppose the object was like this and the image is formed like this. This is called inverted position. If the object is like this and the image is also like this, we call it as erect. Okay, and here the nature is it will form the same size. It will form the same size. The image size and the object size will be same. But here I want to add one more point actually. So here this is the object. Okay, this is the object. This is the object and this is the image. What if I make this a virtual object? Then the image will be formed here only. That means the positions of object and image can be interchanged. So in other words, it is called conjugate points. Okay, they are conjugate positions, and this is coming from a law called principle of reversibility. That means I am saying that if the light ray is coming like this and it is going like this, the image is formed here, right? The image is formed here. So I am back extending them and I am getting the image here. But if I start from this side, that means if I call this object, this track can be perfectly retraced. This track can be perfectly retraced. Okay. So the path in which the original light rays came, you can trace back the same path in the reverse order. That means you can replace object with image and image with object. Now this is called principle of reversibility. We use it in solving many problems. This concept is used. Okay, and the location of object and image, these are called conjugate locations. Okay, if you replace one with the other will replace the prior one. Okay, so so maybe in the next discussion I have to take some problems on this reflection phenomena only. Maybe we'll look into some problems of the plane mirror and multiple reflections, and then we will look into some other aspects of reflection also. Okay, okay. So maybe in the next class I'll come with some PYQ problems related with reflections, and we'll discuss on that. So we can conclude this with a problem on plane mirror reflections problem. We can do one problem on that. Let me select a problem which tests the concept of plane mirrors, what we have discussed right now. So here there is a question. Possibly you can try and tell me the answer. Let me share the screenshot. This problem. A small object is placed 10 centimeter in front of a plane mirror. If you stand behind the object 30 centimeter from the mirror and look at its image, the distance focused for your eye will be how much? You can draw the figure. So it's like this. There's a mirror, and maybe a small object is kept over here, which is 10 centimeter from the in front of the plane mirror. So this is the silvered side. On the silvering side, there will be only absorption. There will be no you cannot reflect. Reflection will be on the other side, which is this side actually. This side only reflection will take place. So if you stand behind the object 30 centimeter from the mirror, so the person is standing here actually, which is 30 centimeter from the mirror. Okay, is asking you and from the mirror and looks at its image. The distance focused for your eye will be. You know that just now you have learned that if you keep the object here, the image will be formed this side. It will be 10 centimeter. Okay, so the man is standing here. So the man will be able to focus the image 30 plus 10, 40 centimeters. Okay, because it is finally the man who is seeing uh, the the image, isn't it? So the man has to focus his eye at 40 centimeters to see the image of the object. Object he will be seeing at 20 centimeters only, but the image he will look at 40 centimeters. So answer is not 20, answer is 40 because he's asking about the image. Okay. So with this, I would like to conclude, and we'll take up some problems regarding this reflection, which are old PYQs of JEE. Maybe in the next session, I'll plan some problems related with the reflection. With this, I'm calling it a day, um, and we'll try to look into some interesting problems of plane mirror and reflection phenomena. And if any additional these concepts are required, I will be teaching in the problem itself. Okay. So thank you for your time. Let us meet next time. Take care. Bye. Okay. So if you see my video, this live session, you're welcome to ask your doubts regarding the problem which I discussed, or if you have some queries, just mention it over there. I will be discussing that live when I come next on air. Okay, and let us form some concepts which we can use to solve real JE type questions. I'm discussing more at the mains level. As the time goes by, I'll pick up some advanced level questions also, which I will be solving using the same concepts which I've been teaching in the class, right from the basics. Okay, okay then, take care, good night.